Alrighty, welcome over to day 14 of Advent to Code. Fingers crossed that hopefully today I can keep up the hot streak I had yesterday, and that things go well on like day 12. Fingers crossed. This year has seemed pretty kind of staggered in terms of puzzles, so I don't really know what to expect anyways today, but let's get into it. Grab our puzzle. Input looks interesting. Alrighty, what we got here? The incredible pressures at this depth are starting to push strain on your submarine. The submarine has polymerization equipment that would produce suitable materials to reinforce submarine at the nearby volcanically active caves. Should even have necessary input elements sufficient for quantities. Submarine manual contains instructions for finding the optimal polymer formula. Specifically, offers a polymer template and a list of pair insertion rules. Your puzzle inputs. You just need to work out the polymer. What polymer would result after repeating the pair of insertion process a few times? For example, is a polymer template. This is the starting process. The following sections define the pair insertion rules. A rule like A, B to C means that an elements A and B are immediately adjacent. Element C should be inserted. So starting with the polymer NBC, the first step simultaneously considers all three parts. The first pair NN matches rule NC, so that element C is inserted between the first N and the second N. The second pair NC matches the rule NC to B, so that means B is inserted between N and C. Okay. Apply 10 steps of pair insertions to the polymer. So what do we get? Okay. I think I understand what this is going for. So let's get our string. This is going to be our polymer, I guess. Input get 0, and then we're going to go for int I equals 2, while I is less than input dot size I plus plus. We're starting at 2 because that's where our input starts, is on the third line, third index, but that's number 2, start at 0. And we're going to go through this and parse it. So we're going to go string s is input get I, and then we're going to go ahead and get our parts again. Is going to be equal to s. Replace this initial, or actually no, sorry, not replace, just split on this. That gives our parts. And I guess we can just build a hash map for this. So string just insertions. Sure. Let's go with that. And then we'll go insertions, put parts 0 and parts 1. There shouldn't be 2 rules, so we shouldn't have any duplicates. That should be easy enough to handle. And so now that we've done this, now we just go through. So for int I equals 0, while I is less than 10, because it wants to just do 10 steps. And we're just going to go through all the insertions, find all of the matches, and insert them, as I believe we're going to do. So we're going to do for string insert in insertions. We're going to do polymer replace all insertions with insert char at 0 plus the let's do a key set, by the way. Then we add on this plus this. It's not I, it's insert, by the way. So that'll go through and actually do the work of inserting. That should handle all these catches of adjusting, because it's going to go through and replace all of them. So if I run this, well, if I run this, nothing's going to happen. Because, you know, I don't do anything with this, is it? Just call a lap on polymer, I guess. Is that what it's asking for? What do you get if you take the quantity of the most common? Oh, my bad. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? Are the elements the letters? Okay, so let's just do this. And this is gonna be counts. I don't know. This is the fastest way I can do off the top of my head. I'm sure there's a faster way, but this is what comes to mind first. For char C. Actually, this should be character, by the way. Char C in polymer. Get or default counts, put C of C or 1 plus 1, C or 0. There we go. And so that should give us this, and then we should be able to do is there a int min integer what max value? There we go. So grab the min and max. Again, this isn't the most efficient in the world. It's just the way I can think of to do at the moment. And then for char C, what the? Char C in counts, key sets. Stop. I don't know what I'm doing there to trigger that. If min is greater than counts get C, set min equal to counts.get C, and then again the opposite for max, just flipping this around. Oh, because this is meant to be min value. There we go, and we can just take max minus min and this in a second should give me a number, which is our input, which is not right. Inserted elements are not considered to be part of the pair until the next step. Oh, I'm doing this too early. Okay. I'm ahead of myself. I see what's going on. This builds up the new string. So okay, so we're gonna do this differently. So what we need to do is we need to go through equals 0 while j is less than the current polymer dot length j plus plus. Instead of doing it this way, replace, we need to go through this and we need to see if the characters here, actually it's me -1 by the way, because we can't, the end doesn't matter. So we're gonna do string let's call this the element. Let's call this pair equals polymer substring j to j plus 2. So it'll be j and yeah, so that gives us 2. And then we can just do a check if the insertions contains this pair. What we'll go ahead and do is then do the new polymer plus equals the polymer char at j plus the new insertion, so plus insertion dot get pair. Otherwise, if this is not true, we will go ahead and just do this. So actually, we should be always doing that. And we can do that. There we go. Always do that. There we go. Sure, create a string builder, that's fine. That goes away. And then after every step, we just do polymer equals new polymer to string. That should then save it to where we only do this turns worth 8. Am I on my input? No. Okay, I figured it out. The string builder was in the wrong spots, and I just did some more logic. It's fine. So this works now, so we can go back to my inputs. Do this again. Okay. This looks like a much better number. Yep. Okay, there we go. Part 2. Rosati polymer isn't nearly strong enough to reinforce. I need to run more steps. A total of 40 steps should do it. Okay, so instead of 10, let's go for 40. This should run fast enough. I thought it was running fast enough. Maybe not. I thought with 20 milliseconds it would, but even a string builder, I guess. Let's see where it's at. Let's see how many steps it's gonna get through. Oh. It gets real slow around there. Okay. Wow. How long is it? Yeah, it's just that exponential growth. It's just so long. What if we, okay, I think I see where this is going. We need to figure out a way to store the number of occurrences that each of these are happening. Hold on. So here's our insertions. What if here we keep track of the pair counts? Let's go to integer. Whenever you have problems like this where you run out of space or things just become too large, the answer is always, how do I break this down into patterns or parts, or how do I break this down into smaller chunks? I've been thinking about this for a while, and I'll have this again when I go over the solution. But you kind of just have to look at the problem, see what it's giving you, and the key is that if it's a pattern, it's gonna be something with like how these are repeating or whatnot. And that doesn't really get me anywhere. But then you go back to this key and you're like, well, we have this key here. How can we use this key to group things? And that's what this key is, just all about grouping. So that's why I'm going to use this key to kind of group things, but keep track of how many each we have. Because when you break one apart, when you take a pair and you kind of do this assertion, you get one pair, and out of it you get 2 of them. So now you can just put this back into the map and keep tracking this way. So we're gonna do, instead of the new polymer, we're gonna do this with our pair counts. So this is going to be, instead this will be new pair counts. And what we'll do is we'll go through string pair in pair counts, the key set. And what we'll do is we'll do the lookup again. So it'll be our insertions get our pair. This will give us our insert. And from this, we now have our 2 parts. This is going to be new pair, or string new pair 1 is going to be equal to the pair of pair char at 0 plus the insert, and then our second pair is going to be the insert plus the second thing, the second letter in this. And then now with the new pairs, now we can go ahead and put these in new pair counts. So we can do put new pair 1, new pair counts, getter default, new pair 1, 0, plus what's currently in our pair counts for this pair, because this pair will create equally as many ones of these, and do the exact same thing for the second pair. Again, this is for the duplicates, because yeah, you'll get ones creating more. Okay, and then at the very end, we do pair counts equals new pair counts. It's always empty because we have to do pair counts, put our input. Okay, we have to go through our input. Equals 0 while I is less than polymer, because we still have our polymer up here, right? Yeah, our polymer length -1 plus. Go through, put our pair counts into here. We'll put polymer substring I to I plus 2. And we'll do, let's just do this. There's our pair. Into pair counts, we do pair and then pair counts, getter default, pair 0 plus 1. There we go. Now we should be good. So now our pair counts, now we're good. We don't need counts anymore because, oh, well, I guess we still do need counts. This one's just going to become remove polymer. It's going to become here's our key set. And then for let's do it this way. S dot char at 0. And this is going to be instead plus pair counts get S. That's where we're adding on how many of these there are. Do the exact same thing for this one. And now, if we run this, fingers crossed, this goes much faster. It's not long enough. We need longs instead of ints. Fingers crossed now. That looks more like it. Part 2. Darn. Oh wait, am I using? I'm not using the wrong. Okay, let me use their input. I think I'm on the right track. I just must have messed something up here. Went 40 steps. What am I looking at here? Oh, print line. Because that should be 0, not the min value. Well, I guess that doesn't matter either way. Why is the min value a really low negative number? Because that's needs to be a long. That was probably what was screwing us up. Or not. Could the pair counts also need a long? I should just use longs everywhere. I should stop using integers for advent to code. Just use longs everywhere. Maybe. Changed. That looks not right. We have exactly double, or not exactly double, but like basically double what it should be. Why do we have double what it should be? I mean, like, I swear. Like, I mean, I'm right there. I could be off by 1. Why am I having double? Something is, I mean, okay, let's put my input in. Let's just see if I can get this right. Let's see if mine happens to be right. It's not, okay. So I'll submit here in a second. It's doubled because every pair, oh. I see why it's doubled. It's because I'm taking the pairs, but then the pairs share a letter. Oh. How do you fix that? How do you fix that indeed? Yeah, so there's the answer. So the answer is this right? Is it that? Because I would have it, but then you have an extra 1. Okay, so this is right. I just don't know how to fix this. Okay, let me go through. We got part 2 done now. Let me go through and clean up my code, try and figure this out, and then I'll come back to you guys and explain my solution here. So 1 minute. Okay, so I've gone through, cleaned up the code. I still don't know for sure if this is the correct way to do the math on the final count, but I'll get to that later. So first off, TLDR is that you are given this input here. This input has a polymer, they're calling it here, which is a bunch of just kind of letters here. And after that, you have a bunch of kind of rules of how those letters will transform the given polymer. So you basically will say this pH, you take groups of 2 polymers, or groups of 2 elements, I guess what they are, 2 letters here, and you will look it up in this table. I don't know where pH is. Let's see if we got lucky and I just happen to see it. No, not lucky enough to just pluck it out of this table. Oh, there it is. So pH here, as you can see, pH goes to H, which this means is that an H will be inserted in between the letters P and H of this element, or of this pair of elements here, and we replace that, but that goes into the next step, I guess. So this, for every step, this polymer stays the same, so you apply all these rules, but the rules get built onto the new polymer after it. So the PHH is what this would come out to, doesn't get read by any of the following kind of rules you go through here. It's just this every iteration, I guess, kind of the best explanation, but that's what it means. So that's what the problem is. I'm only going to cover one part because part 1 and part 2 are the exact same, just different amount of steps. So I won't cover them both differently. They'll be kind of wrapped into one. But anyways, so the first thing we do is grab our polymer, which is the 0th index. Just grab this, save as a string. And then we have to go through and map up all of these into a map, with the key being the pair of elements and the value being the new element that's added between these. So you go through here, we start at 2, you start at index 2 because, again, the first index is the polymer and the second one's a blank line. So we start at the second index and then read the rest of them, just splitting, putting them into our map here, and that's it. And then we get into the actual work of this. So they just part 2 here. So we go and we first start by calculating the pair count. So this goes back, I'll go back to what I said earlier if you kind of skip to this point. There is a naive way to do it, and if you didn't watch part 1, I did the naive way, in which I kind of just went through, did a bunch of replaces, did a bunch of kind of substringing and all that, and I got the answer for part 1. It does not work in part 2, as it gets really, really slow and is just too slow, and you get way too long of a string. The biggest thing is that the string becomes way too long to compute and continue to work with. When you get to that point, you have to kind of think to yourself, okay, my issue is I have a too large number or a too large of string. How do I break this down into a much more manageable parts? With Advent Decode, that is happens a lot. So whenever you have slow run times, you always kind of think to yourself, okay, how do I break this down and make this more efficient? And it usually boils down to one of two things. Either there is a pattern or there is a way to group things. They both kind of fall into the same kind of solution. But in this case, I had looked on here for if there was a pattern. I couldn't really see anything, whatnot. But when you get started talking about grouping, well, you have this table right here, which is just groups. This is literally gives you the groups that you're using. So what that means is that instead of looking at the string of a whole and creating a new string from this one, we can look at this in the scope of the pairs. And if you look at it that way, basically we can just keep track of, not these are different projects, sorry. We can just keep track of how many of these pairs we have in our string. And we are allowed to get away with that because, well, every iteration, every step, we're just taking these pairs and creating, or we're taking a pair and creating two new pairs from it. This CH becomes CB and BH. It's just one pair is now split into two and modified. And from that, we now know the counts of all the pairs for the next step. So we can just go through each step, create a new hash map for our pairs. This is the element pair, and this is how many times it occurs. We can just go through, save the pair count first, find the insertion that this pair is representing. So in the case, I keep going to the wrong thing, sorry. In the case of this CH here, so if we pull out a CH, we have the number of times the CH occurs, but the most important thing is we want to know what letter is going between this. The insertion in this case is B, so we pull out that CH, this is a B, and what this means here is that our new pair 1 is now going to be CB, new pair 2 is going to be BH, and that means when we go ahead and put these in, we're going to put in CB is going to be equal to the existing pair count that we have, plus any other pairs that happen to make a CB as well, and then do the same thing for CH, I think I did that backwards, or BH, either way. And we just keep doing that. We make this much more manageable because we have a lot less, we don't have a giant string, we just have 8, 10, whatever, and how many of our indexes this is. We only have 100 indexes of pairs as opposed to a billion long string. So this makes it much more manageable. And in the end, when we return this, we can then just go ahead and count the number of letters. This gets a little bit complex. There's a pi is a much more efficient way. Basically, I just go through all the pairs, I break them out into individual chars, save into a counts of char and long, so kind of break them all into individual pairs, add them all up that way, and then go through a whole min-max of those pairs there. You probably could make it a little more efficient. But in the end, we get to this point, though, we have an issue. Because we've gone by saving them in the pair counts, remember, 2 pairs forms 3 characters. So you have a issue where, 2 pairs is 4 characters, but in the form of a string, it only makes 3. You lose 1 character because 1 character is duplicated between 2 pairs. So what ends up happening is that when you kind of do a solid math up, you have double the count of what you should be at. Now, I don't know if this is the right way to solve this or this is the kind of the actual way. I don't know here. This is what I did. This works. Doesn't mean it will always work for you. Doesn't mean this is the right way. So that's what I did. I'm not going to highlight too much more on that, on why this is it. Just know that we have the double the count that we should, because we're counting characters twice in a sense, in that, you know, the 4 and the 3 and whatnot. So at any rate, there we go. There is day 14 complete. Hopefully my explanation helped you or made it more better. Hopefully you enjoyed this day. Thanks for watching. I guess see you guys tomorrow for day 15. Peace out.